Good afternoon, this is Schweitzer, and we're going to be putting together a little video here on Smart Notes for Hess's Law. Now, what is Hess's Law? So whenever I talk Hess's Law, we're looking at it in terms of like an everyday situation. Hess's Law, if a reaction is added up, all the overall reaction, the new overall reaction, then the amount of energy exchanged during those reactions will also add up. So here's kind of how I look in terms of money. Now remember, reactions tend to have multiple elementary steps. Step 1, step 2, step 3, step 4. You're making money. You mow lawn, you make $50. You clean out gutters, you make $150. You walk 2 dogs, you make $25. You get her she gets her fingers and toenails done, so she gets something fun for herself. Okay, so minus 75. How much money is left over? So all these things add up to the overall net amount of money. Same thing if you have elementary steps, and you have step 1, is endothermic for positive 10, and then your step 2 is exothermic for negative 10. Then in step 3 is exothermic for negative 10. Then in the end, when you add up all your stuff for your overall reaction, X going to Y, your delta H is going to be negative 10 kilojoules per process. So all my delta H's add up, and this, of course, the elementary steps add up to the overall, which we've done much before. Here's our notes on that. All right, so let's look at just a general example. First thing we want to be able to do is add up the reactions. And if we do here, we have an intermediate. Depending on how well you are at adding these up, I'm sure you're starting to get better at it. So this is going to be 2x plus, it's just 2x goes to m plus z. These two reactions add up to this reaction, so my delta H for this reaction is positive 5. Simply add them up. All right, there we go. Again, lots of ways to add these up, but my y's would be an intermediate, which would cancel out. And there's my overall answer. Okay, let's try a little more of a chemistry version. Now, how Hess's Law, if it adds up, so will the enthalpies. Okay, so now this is what I call a little bit of a game. Just a little bit of a game I play here, where I'm trying to get this thing, I want this reaction. So what they do is they give you some elementary steps or some half steps or whatever. And what I want to do first of all is make sure that I don't have to flip these things. So what I mean by that is that a reactant should be on the reactant side. Now this first one, you notice that this guy here, the methane is a product, but on this guy, it's a reactant. So I'm going to flip this guy so at least my reactants and products are on the same side. We've talked about in the past that if you have to flip a reaction, then your delta H, the sign flips. Energy in equals energy out. So this thing flips. So we have sign, and then so first we do is we check to see if if we need to flip anything. Okay, now typically on the fly I wouldn't rewrite these things all the time, but I'm going to take a moment here and just change it to C. Let's do it right here. CH4 goes to carbon plus 2 hydrogen, and now it's going to be a negative 74.8. Again, I would go through this little process, and then I would assume it would work. I wouldn't go through and add it all up again. This guy, carbon dioxide, is a product, and it's a product. You don't need to check every one of them. Just check one of them. Make sure. Hydrogen is a here, and it's a not in here, so let's go to a different one. Water. There is product here, product here. Okay, also note you can cancel out intermediates as well. They need to cancel. That might be another reason you could figure out something needs to get flipped. This one, however, is staying the way it is because it's lined up correctly. Next thing, do I need to multiply or divide anything? Keep in mind that if you multiply your delta H by 2, then your delta H just goes times 2. Anything you do is proportional, so times 2. We'll see that in a second here. So in this case, 1 carbon, 1 methane, 1 methane. The numbers are correct, so I don't need to multiply it all. Carbon dioxide is 1. So there's 1, that's good. And my water is 2, so I need 2 waters. So that means I got to multiply this whole thing times 2. So this is how I do this. 2. 2 halves is just 2. Alright, that's how I multiply that times 2. And then 2, and this gets multiplied times 2. And this is a negative 482 kilojoules. Okay. With that being said, now you can go ahead and rewrite this out. C plus O plus CO2 is negative 393, and then 2H2 plus O2 yields 2H2O, negative 482. And of course, all this will add up to its new delta H. And that's the answer for that particular question. And that's how this thing generally works. Let's go ahead and let's add that up here quickly. I'm assuming you can add that up on your own. That's no big deal. Okay. But the overall process is the same for every one of these problems. You just, do I need to flip anything? Do I need to multiply and divide everything? And of course, when I go through those processes for each one, I don't then re-add this up again. I assume if I've gone through all my checks that the reaction will in fact add up to the overall reaction, and then I just add up all my delta H's. Okay, Hess's law, another example. Okay, hydrogen peroxide H2O2 decomposes into water and oxygen by the following equation. There we go. Determine the half reaction, delta H for the reaction following the information. Okay, so they're giving these things. This is just how this works. Try this example on your own. Pause the video. I'm going to be going through the answer very quickly. All right, here we go. First thing you do is, does anything need to get flipped? In this case, these are on the opposite sides, so we've got to flip this one. This one's correct. This one got reflipped. All right. Do I got to multiply and divide anything? I got, in this case, water. Water's a product. Okay, so here, do anything need to get flipped? Make sure the quantities match. Okay. And do they match? Well, I got 1 H2O2. We got 1 H2O2 here. I got 1 water here. I got 1 water here. Should work out. And in fact, if you cancel out, you get half of water here. Half and half. I don't think everything seems to match up nicely. Do quantities match? And the answer is yes. Intermediates match up as well. Add them up for overall reaction, which of course, if you've done that, it should add up. Which does. And then you can simply add up your delta H's. Here's another question for you to try. Okay, a little bit, not a huge difference. Pause the video, try it on your own. Okay, we'll be going through the answers here quickly. Again, it may look a little bit different, but all they're doing is really adding things up for you. Okay, giving you this, it's written a little differently, but the same thing. They're giving you 2 reactions with delta H's, and they want you to find this one. Go ahead, pause the video if you have not yet, try it on your own. First things first, they're flipping one. Multiply the bottom times 3. And my reaction adds up to the overall now. Yeah, I would assume it would. I wouldn't necessarily go through all this work. Add these up, and I get my overall reaction. Thank you very much.